Lesson outcomes. This is the very important section because it tells you that at the end of the lesson, what you should know and what is important. So, on completion of this module, the student must be able to change from Celsius to Kelvins and Kelvins to Celsius, vice versa. Analytically solve practical problems on the expansion of solid to temperature changes, area and volume expansion. So, what I forgot to include here is the linear expansion which we have done from N1 until N3, an area expansion which you have done in N3. The only new section that we're going to deal with is volume expansion. But volume expansion, it only means we're having three sides. And with area, we're having how many sides? Two sides. So that's the only thing. Analytically solve problems on volumetric expansion of liquids as a result of rise in temperature. Be aware of anomaly in the expansion of water, reproduce the laws of Boyle's and Charles, but we won't be dealing with this now. We'll see it on our next slide, which is going to be our lesson 4. So for now, we'll be concentrating on area expansion, linear expansion, and volumetric expansion. Then we'll start with coefficient of cubic expansion since it's the new section here in N4. Linear and area, you guys are familiar with it. So the only thing that we're going to do with linear and area is just to do examples so that we remind you. So coefficient of cubic expansions, as you can see with the drawing, it's having how many sides? 1, 2, 3. So meaning you're going to have meters, and meters, which will give you what? Meters cubed. The coefficient of cubic expansion. The cubic expansion coefficient of solid is an increase of a unit volume of a substance per degree change in temperature. So here they're explaining how do you end up having what? Meter cubed, and here you're having what? A coefficient of linear expansion. Then we're having a coefficient of linear expansion squared, coefficient of linear expansion cubed. Then here they're explaining that a cubic expansion is the same as 3 multiplied by a linear expansion. Coefficient of cubic expansion. When solid is subjected to a change in temperature, the change in temperature is proportional to the original volume and the change in temperature. So we're going to have T volume at temperature T1, volume at temperature T2, where our T1 is initial temperature, T2 is our final temperature. This represents your cubic expansion. Change in volume. Your change in volume is given by what? Original volume multiplied by cubic expansion multiplied by change in temperature, which is T2 minus T1. That's what they're showing you here. Then we're having V2 is the same as V1 plus change in temperature. This is the formula for final volume. It's just that now they're using V2 and V1. For your original, they're using V1, and for your final, they're using what? V2. Then we're having worked examples. In this example, if you check the look, they say calculate the increase in volume if the temperature increases by 80 degrees and the linear expansion coefficient of the material is 17 multiplied by 10 to the power minus 6. So the first thing that we have to check is what are we given and the unit. What is the unit for our coefficient of linear expansion and our unit for temperature? So the most important thing, the moment they say something increases by, it means this is your T2 minus T1. This is your change. The word by tells you that is change. So since we're dealing with volume here, the first thing that we're going to do, as they did with the example, they multiply their linear. We're given linear and they say calculate the increase in volume. And in volume, we're having what? Cubic expansion, not linear. So we have to multiply by what? By 3. Then after we use the formula for change in volume, which is what? Cubic expansion multiplied by original volume multiplied by change in temperature. And I said your change in temperature given what? T2 minus T1. Hence, they say increases by. Then we'll move to the next example. Then in the next example, uh, still the questions that they've been asked, they're looking for increase in volume. Increase in volume is the same as your change in volume, which is what? Cubic expansion multiplied by initial volume multiplied by change in temperature. Again, here we are given our linear expansion in per degrees Celsius. So we have to multiply it by what? By 3, because volume works with what? Cubic function, cubic expansion. Hence 3 multiplied by linear expansion multiplied by original volume multiplied by change in temperature. Again, here for our change in temperature, they said increase by, meaning this represent what? Our T2 minus T1. Then for C, they're looking for final diameter. Then they use the formula for volume. Then they got the value for volume. Oh, and I skipped number B. Number B, they're looking for the final volume. Final volume is the original volume plus change in volume. Then the question says calculate the increase in area if the temperature increases to 100. Here we're given T1 and T2. Our formula for increase is going to be changing area is the same as original area multiplied by area expansion or superficial expansion multiplied by changing temperature. So here we're given a brush sheet 400 millimeters. So an area of a brush sheet, it's a square. So a square, we're going to say what? 400 multiplied by 400, hence is 400 what? Squared. Then you get your answer. Again, then we do our next example. An area of a brush sheet is 1 centimeter squared at 0 degrees Celsius and 1,0036 centimeters squared at 100 degrees Celsius. Okay, meaning that here we're having an increase here in increase in area. Then they say calculate the coefficient of linear expansion. As you can check here, A2, which is our what? A2, which is our final area, minus A1, which is our original area, over A1. So just use the formula for change in area, then you'll get your answer. Change in area is the same as original area multiplied by superficial expansion or area expansion. Then you will get your answer. So the answer that you'll get here is area expansion or superficial expansion. So we have to divide by 2 to get our coefficient of linear expansion. Then we come to important formulas for solids and liquid, where there they say T is the same as T minus T original. That's how you convert from Celsius to Kelvins to Celsius. Then we come to the formula for changing length. Changing length is the same as coefficient of linear expansion multiplied by original length multiplied by changing temperature. Then when we come to area, changing area is the same as superficial expansion or area expansion multiplied by original area multiplied by changing temperature, where our area expansion or superficial expansion is the same as 2 multiplied by coefficient of linear expansion. For volume, is change in volume is the same as cubic expansion multiplied by original volume multiplied by change in temperature, where you change in temperature is T2 minus T1. Then volumetric expansion is the same as 3 multiplied by coefficient of linear expansion. Thank you. That is the end of the lesson.